Hello kids. So some days before I kept a question on my YouTube channel in the post, and this was the question there. Today let's see the solution for this question. Okay. So let's start reading the question. In the diagram given below, there are three lenses formed. Okay. Consider negligible thickness of each of them as compared to R1 and R2. Okay, that is radii of curvature for upper and lower surface of glass lens. The power of combination is, okay, so this is the combination that is given to us. This is the first lens, this is the second lens, and then this is the third lens which is being formed here, right? And they have given the radius of curvature of the upper surface as r1 and the lower surface as mode of r2, mode of r1 and mode of r2, and they have given the refractive index of the three mediums which are used here. So they have asked us to find out the power of combination. So let's identify, let's see what are the lenses formed. So the first lens that is formed is plano convex lens, right? The second lens that is formed is concavo convex lens, and the third lens which is being formed is plano concave lens, right? So these are the three lenses which are being formed here. Let's see how you will be able to find out the power of the combination. So first is plano convex lens, then is concavo convex lens, and the third is plano concave lens. Now we know the equivalent power is equal to the sum of the power of individual lenses, right? So equivalent power should be P1 plus P2 plus P3, and power of individual lens is reciprocal of its focal length, right? So can I write the equivalent power is P1 plus P2 plus P3, and the power of the lens is inverse of focal length. So P equivalent is equal to 1 by F1 plus 1 by F2 plus 1 by F3, where F1, F2 and F3 are focal lengths of the three lenses formed, correct? Now we are going to use the lens meter formula to calculate the focal length of each lens. What is the formula? The formula is 1 by f equals to mu l, where mu l is the refractive index of the lens, divided by mu m. Mu m is the refractive index of the medium, minus 1. 1 by r1 minus 1 by r2. What is r1 and r2? Do not get confused with this r1 r2 and with this one r1 and r2. This r1 and r2 represents the corresponding radius of curvature of both the surfaces of the lenses. Means, for example, this is first surface, this is the second surface for the first lens. So r1 represents the refractive and radius of curvature for this surface, and r2 represents the radius of curvature for second surface. Okay, now we will find out the individual focal length of the three lenses. So by using the lens meter formula, the focal length of the first lens will be 1 by f1 equals to mu l lens. What is the mu l given for the first lens, which is 4 by 3, divided by mu m. Now if you see, all the three lenses are having their own medium, right? So we will be finding out the focal length with respect to the air, right? And the refractive index of the air is 1. So by 1 minus 1, correct? Now the first lens is plano convex lens. For plano convex lens, for plane surface, the radius of curvature is infinity. So 1 by infinity minus. Now if you say, see, the ray is coming from this direction and the radius of curvature is in the opposite direction, right? So minus and minus of mode R1, correct? So if I will solve this, 1 by f1, 4 by 3 minus 1, 1 by infinity plus 1 by mode of R1. 1 by f1 is equal to 1 by 3, 1 by infinity will be 0, so 1 by mode of R1, correct? So this is your 1 by f1, so your f1, your 1 by f1 is 1 by 3 mode of R1, right? Now see, let's see for the second lens. Second lens is our concavo convex lens. Again the lens meter formula, 1 by f2 equals to, now what is the refractive index of the lens? It is given 3 by 2. Again with respect to air, 3 by 2 divided by 1 minus 1, 1 by. Now the first surface is R1. So minus mode of R1, right? Because the light is still coming from this side and the radius of curvature is in the upward direction. So minus of R1 minus. Now for R2 also, if you see, the radius of curvature is in the upward direction, whereas the light is coming in the opposite direction. So it will come minus R2, mode of R2, right? So 1 by F2, 3 by 2 minus 1 minus 1 by R1 plus 1 by mode of R2. If I'll solve this, 1 by F2 is equal to 1 by 2, 1 by mode of R2 minus 1 by mode of R1, right? This is your second, this is your second power, correct? Now let's see for the third lens. Third lens is plano concave lens. So 1 by F3. What is the mu given for third lens? 4 by 3 minus 1 minus 1 by R2 minus infinity, right? So 1 by F3 is equal to 1 by 3 minus 1 by mode of R2. So our F1 by F3 is this one, by 1 by F2 is this one, and 1 by F1 is this one. Now let's find out the P equivalent, which is equal to 1 by F1 plus 1 by F2 plus 1 by F3. 1 by F1 is 1 by 3 R1. 1 by 2, F2 is equal to 1 by 2 mode of R2 minus mode of R1 plus minus 1 by 3 mode of R2, right? Let's find out 1 by 3 mode of R1. Let's take out R1 things one side and the R2 things other side. 2 R1 minus 1 by 3 R2. Okay? So R1 1 by 3 R1 minus 1 by 2 R1, right? Plus 1 by 2 R2 minus 1 by 3 R2. Let's take the 6 mode R1, 2 minus 3 plus 6 mode R2, 3 minus 2. So minus 1 by 6 R1 plus 1 by 6 R2, right? Now let's take 1 by 6 or minus. Let's see what are the options given. The options are all the R1s are positive. So R1 should be positive. Hai na? So let's take minus 1 by 6 common. 1 by R1 minus 1 by R2. So this is our net equivalent power. Okay. So what is the correct option? I think option B is the correct answer. Okay. I think this is clear. For more such videos, for more such doubts, if you have any doubts, if you want me to post the video for such solutions, please put it in the comment section. If you like the solution, if you want more such videos to come up, please follow our channel Magic Mentor. I'm your Magic Mentor, Chavi Bansal. Thank you so much.